Okay, today we're going to take a look at solving inequalities, addition, subtraction, multiplication, and division. So turn in your textbooks to page 498. If at any point in time you need to pause the video to try a problem or to catch up on something, pause and you can resume at any time. Remember that you can also go back and re-watch any portion if it's not making sense. Back in our 6th grade book, we talked about solving inequalities. The cool thing about inequalities is that we solve them the same way we solve equations. The only thing that's going to be new today is that we're going to now be utilizing all integers, so including our negative numbers when we solve. So remember, to solve inequalities, we're going to solve like an equation. So here in the middle of the page you see our symbols. You see first less than. So that's this symbol here. Then we have greater than, we have less than or equal to, and then we have greater than or equal to. So these are the 4 symbols that we're going to use today as we're working. So let's take a look at this first example, example number 1. I have x plus 3 is greater than 10. So we're going to solve this like an equation. X plus 3 is greater than 10. Well, I would have to get rid of the plus 3 to get my variable alone, so I'm going to subtract 3 from both sides. So now I get a 0 pair, I'm left with x is greater than 7. So I could go ahead and graph this on a number line. I'm going to put 7 in the middle, and I'll get 2 to my right and 2 to my left. I'm going to use an open dot because x is greater than 7. It means it cannot equal 7, so I need an open dot, and it's greater than 7. So it's all the numbers that would be bigger than 7 on this number line. And make sure that you include your arrow going to the right. Remember that we use the closed dot if it's equal to, and the open dot if it's not. Look at the top of 499 with me. We have a little bit of a different structure here in this problem. So I have negative 6 is greater than or equal to n minus 5. So if I want to rewrite this, which many of you I think will probably want to, I would go ahead and rewrite this first. So if I move n minus 5 to the left side of my inequality, what's going to happen is that this sign here, I have to take a look at, because negative 6 was greater than. So that means that n minus 5 is actually less than or equal to. So I'm flipping the sign if I rewrite this to negative 6. You could leave it just like this if you want. It will solve the same. So I would add 5 to both sides. So I'm left with n is less than or equal to negative 1. If you kept it the same, negative 6 is greater than or equal to n minus 5, you'd add 5 still to both sides, and you would get negative 1 is greater than or equal to n. Well, that's kind of confusing when you go to graph it. So if we flip it here, and I move my n, I would have to also flip my sign to less than or equal to negative 1. Now that's pretty easy to graph. I put my negative 1 in the middle. Here's 0, 1, negative 2, and negative 3. It's going to be a closed dot because of the equal sign, so it's including negative 1. So a closed dot at negative 1, and n is less than or equal to, so it's got to go to all the values that are smaller than n. Okay? Go ahead and I'm going to have you pause the video and try these got it problems here in the middle of the page. Go ahead and do that. Okay, go ahead and check your work with mine now. On the first one, we should have added 3 to both sides. A is less than 11. The sign stayed the same because we weren't changing positions. And letter B, y is greater than or equal to 6 and 6/10. When I graph this, you could do 6 and 7 and graph in between there, but this would be a little bit more accurate with your decimals. Okay? Go ahead and look with me at example 3. Now I have a plus 11 is less than 2. Okay, so if I go about solving this the same way as I solve my equations, okay, a plus 11, this will cooperate, that'd be great. So a plus There we go. Now, a plus 1/2 is less than 2. So I'm going to subtract 1/2 from both sides. So A is still less than 2 minus 1/2 would give me 1 and 1/2. If I graph that, I could probably just do 1 and 2 here. And 1/2 would be right here. So that would be my 1 1/2, which it's less than, so it's going to be open dot and going to all the values that are less than 1 1/2. Okay? So addition and subtraction are really going to work pretty similar to solving just addition and subtraction equations, unless you have to flip them from left to right. Let's take a look at multiplication and division. Turn with me to page 506. With the positive numbers, our multiplication and division is going to work the same as our equations. So if I have 8x is less than or equal to 40, I would divide both sides by 8. So I'm left with x is less than or equal to 5. I'd still graph that the same way. So here's 5, 6, and 7. Here's 4 and 3. It's less than or equal to, so it's going to be a closed dot because it's including it. And it's less than, so I'm going to all the numbers, all the values that are less than 5. Number 2, very similar. D divided by 2 is greater than 7. I would have to multiply both sides by 2 to get my variable alone. Those would make a 1, so I'm left with just D is greater than 14. So if I graph that, there's my 14, 15, 16, 13, and 12. It's open dot because it's not equal to, and it's all the values greater than 14. So positive numbers are going to work the same as what we had in our 6th grade book. We're just going to solve them like we do equations. Just be careful on a question like letter B. So if I have something like 6 is greater than or equal to x divided by 7, we'd multiply both sides by 7. So I'd get 42 is greater than or equal to x, because those would cancel. But if I want to rewrite that and flip these two around, if I flip them, I have to also flip the sign. So this would become x is less than or equal to 42. And if I read that, if I read this backwards, x is less than or equal to 42. So this would be my solution when I graph it. Okay? So multiplication and division with positive numbers is going to work similarly. Let's look on 507 now together. When we have a negative number, so here in our key concept box, it talks about this. When we multiply or divide each side of an inequality by a negative number, the inequality symbol must be reversed for the inequality to remain true. Okay, so if we have something like this example here, in number 3, negative 2g is less than 10. Well, I would be dividing both sides by a negative. Anytime I multiply or divide by a negative, it is going to reverse the symbol. So as soon as I see these negatives, this symbol right here is going to reverse. Instead of less than, it's going to become greater than. So I now have g is greater than a negative 5. And when I would graph that on the number line, it's not equal to, so it'd be an open dot, and it's all the values that are greater than negative 5. Look at number 4. Here I have x divided by negative 3 is less than or equal to 4. Well, I'm going to multiply both sides by a negative 3. The minute I'm multiplying or dividing by a negative, I know that this sign right here is going to reverse. So instead of less than or equal to, it becomes greater than or equal to. So I'm left with x is greater than or equal to negative 12. If I graph that, here's my negative 12, negative 11, negative 10, negative 13, negative 14. It's going to be a closed dot because it's equal to, including that value. And it's going to be all the values that are greater than negative 12 going to the right to get greater values. So if you multiply or divide by a negative, must flip or reverse the inequality sign. Okay, this is a really, really, really important rule. It only applies to multiplication and division. So as you're working, if you see a negative that you're dividing by or multiplying by, you need to flip your sign. Go ahead and take a minute to do the got it, letter C here at the bottom of the page, and pause the video. Okay, go ahead and check your work with mine. Because we are multiplying by a -2, which we saw here, the minute I see this negative that I'm multiplying by, I know that's going to reverse my sign. So instead of less than, it became greater than, -18. It's not equal to, so we have this open dot at -18, and it's all the values greater than -18, so it's going to the right. Okay? I'd like for you to take a moment to watch the next video here in the set, and once you have watched that, then you can try the problems that are attached to your Google Classroom. Good luck!